The next thing that we want to talk about when we discuss area and volume in calculus is to look at the volume of a solid formed by revolving a particular region about the x-axis. And the region that we're working with here is a region that's bounded by the x-axis by the graph of f of x is equal to 1/2 of x squared, and we have the line x equals 2. So let's take a look at what that might look like. So we have the graph of y equals 1/2 x squared. We have the x-axis below it. I'm going to have the line y equals 2 above it, or on the right side of that. So what we want to do then is take that little triangular region and spin it around the x-axis, and you should see what's going to form out of that. It's kind of like a cone, but it has slightly curved sides to it. So it will look something like that. And each cross section of that perpendicular to the x-axis, each slice of that will be circular. And because it's circular, it will have an area of pi r squared. And if we add a little height to that, a little thickness to that circle, we will then get a cylinder, a slice of a circle that will have volume to it. And in this case we have pi r squared. Well, the radius is just the height of the function at that point. And the thickness of it, or the height of the cylinder, is going to be dx. So the volume of one of the little slices, or the small amount of volume, will be equal to 1/2 x squared squared times dx. So it's pi r squared, and we still need a pi in there. Okay, so the little amount of volume contained in each slice of that cone-shaped object is given by pi times the radius squared times the height, where the radius is 1/2 x squared, the height of the curve at that point, and the height of the small cylindrical shape is going to be dx. So if we wanted to add up all of those slices, the volumes of all of those slices together from 0 to 2, we'd get pi integral from 0 to 2 x to the 4 dx, and I can bring out the 4 also, and my final formula then is pi over 4 times the integral from 0 to 2 of x to the 4th dx. And all I need to do now is solve that integral, and it will give me the volume of the shape that I'm looking for. So I have pi over 4 integral from 0 to 2 of x to the 4th dx. I'm looking for the antiderivative of x to the 4th, that's x to the 5th over 5. I bring out the constant 1/5, and I want to evaluate x to the 5th from 0 to 2. So I have pi over 20. Evaluating 2 to the 5th is 32, and 0 to the 5th is 0. And that simply gives me 32 pi over 20. Dividing top and bottom by 4, I'm going to get 8 pi over 5. And so that's a simple example of how we would find the volume of the solid formed by revolving this region that's bounded by the x-axis. The graph of f of x is 1/2 of x squared, and the line x equals 2 on the right. Okay, so that'll do it for this video and for this example.